Good morning everyone. Welcome to Narayana online video classes. Today for class 7th students we are going to study logarithms. In that particular logarithms topic we are going to study laws of logarithms. Okay? What are the laws of logarithms we have? We are going to discuss them. At the same time we are going to solve few problems based on those laws of logarithms. Now we have three very important laws of logarithm. They are said to be the first law, second law, third law. The first law is log x base a plus log y base a is equal to log xy to the base a. Okay, whenever you are summing up two logs with the same basis, we can write it as a single log by multiplying the arguments to the same base. Okay, this is the first law, and this law is said to be law of addition. In this direction, if you see, we are adding up two different logs with same basis, so that we are writing it as a single law by multiplying the arguments. Fine. Otherwise, we can call this particular law as law of multiplication also. Okay. From here, if you see, if you multiply two terms x and y to the base a, log xy to the base a, we can write as log x to the base a plus log y to the base a. So this is law of addition or law of multiplication. Second one, or product law, we can call it as product law also. Next, second one, if you see, log x to the base a minus log y to the base a, means if you are subtracting one logarithm from the other, okay, where if you observe here both have the same basis, then we can write it as log x by y to the base a. So this is called as law of subtraction, or this is quotient law, because if you say log x by y to the base a is equal to log x to the base a minus log y to the base a, so this is said to be quotient law also. Now if you look at the third one, log x to the power m to the base a is equal to m times log x to the base a. This is called as law of powers, or power law, or power rule, whatever. This is how we have three very important laws in logarithms which are very useful in solving the problems based on logarithms. Now we will brief how we got these results. Okay. Now let us take log x to the base a as some p. Okay, then as log x to the base a is p, we can simply say that x is equal to a to the power of p. That is a very basic definition of logarithm. Next, let us take log y to the base a is equal to q. That implies y is equal to a to the power of q. That we call it as condition 1 and it as condition 2. Let us multiply these two. 1 and 2, if you multiply, condition 1 into condition 2 implies xy is equal to a power p into a power q. That is otherwise a power p plus q. Okay, a power m into a power n is a power m plus n, law of exponents. That implies xy is a power p plus q. Therefore, I can say log xy to the base a is equal to p plus q. Again, the very basic definition of logarithm. That is equal to, we have p as log x base a plus q as log y base a. Therefore, we have log xy to the base a is equal to log x to the base a plus log y to the base a. Okay, so this is how we can prove the first law. What we are taking, log x to the base a we are taking as p, and log y to the base a as we are taking as q. Then we are multiplying these two and we are using law of exponents. Again, the basic definition of logarithm we are applying, so that you get the required resultant answer, log x y to the base a as log x base a plus log y base a. That is the first law. Now we will see the second law. Same way, for the second one also, log x to the base a as p, that implies x is equal to a power p. Same log y to the base a is equal to q, it implies y is equal to a power q. As usual, it is first condition and second condition. This time let us do 1 by 2 implies first condition by second condition. What do you have now? X by y is equal to a power p by a power q, that is nothing but a power p minus q. Again, laws of exponents we are using here. That is otherwise log x by y to the base a is equal to p minus q, where p is log x base a and q is log y base a. That's how we got the result. Log x by y to the base a as log x base a minus log y base a. That is the second law. Now we will move to the third law. What is the third law? Log x power m to the base a is m log x to the base a. Okay, now let us take log x to the base a is equal to some p, right? That is otherwise x is equal to a to the power of p. Now here we have x power m. The same thing let us do. Let us raise the power of x to m. What do you have then? X power m is equal to a to the power of p or to the power of m. That is nothing but a to the power of pm. Now x power m is a power pm. That implies log x power m to the base a is equal to m times p. Pm or mp, both are same. That is equal to m times of p is already we have log x to the base a. Therefore, the result is that log x to the power m to the base a is equal to m times log x base a. This is the third law. This is how we can prove all the three laws of logarithms. Now, if you look at this, here what is x, what is y? While defining the logarithm itself, we have defined that logarithms are not defined for, only defined for positive real values. So obviously whenever you have given these laws, it is by default understood that x comma y both are positive real numbers. What about a? A is also a positive real number and a should not be 1. These conditions will automatically apply whenever you are using logarithms. So this is very important. Here x and y as well as a all must be positive real values, and there is a restriction on the value of a as it is in the base position. The value of a should not be 1. Okay, these conditions should be followed. Here m can be any real number, no restriction on m. Okay, m can be any value, but x, y and a must be positive real values and a should not be 1. These are the conditions that are to be obliged if at all you want to apply these three laws of logarithms. Okay, now in addition to these three laws of logarithms, we have some more important results which you have to remember, which you have to learn to solve the problems based on logarithms. What are they? Log a to the base b power n is 1 by n log a to the base b. Okay. Next, log a to the power of m to the base b to the power of n is m by n times of log a to the base b. Next, log m to the base a, we can split the base as log m to the base b into log b to the base a. Finally, these two will cancel and resultant is m to the base a. Next, log a to the base b, here we can write it as log a base m by log b base m. Sometimes it necessitates us to change the bases, so we can do that using this. Next, log a base b, log a base b we can write as 1 by log b base a. Here these two will interchange, argument and base will interchange if you write it as its reciprocal. So these are another important rules, another important results which you have to remember while solving the problems based on the logarithms. In addition to that, already we have seen a power log n to the base a is always equal to n. Okay, in our previous class we have seen that a power log n to the base a is always equal to n. So these are very important conditions we can use while solving the problems based on logarithms. Today we are going to solve few problems based on these laws. Fine, let us start. The first question is, write 2 plus log 3 to the base a as a single logarithm. Two plus log 3 to the base a as a single logarithm. We have two terms here. We have to make it as a single term. How to do that? we have 2 plus log 3 to the base a is equal to 2. I will write as 2 times log a to the base a. We know that log a to the base a is always equal to 1 provided a is not equal to 1 and a is a positive real number. Those conditions will automatically apply. Okay, they must be applied here. Now plus log 3 base a, that is equal to, if you look at this, 2 can be sent it to the power position, because power rule I have log a power m to the base b is log m log a base b, otherwise m log a base b is equal to log a power m to the base b, or log a power m to the base b is m log a to the base b, whatever. So we have m log a to the base a, 2 log a to the base a, I can write it as log a square to the base a plus log 3 to the base a. If you look at that, both have the same basis. In between we have sign as plus. So addition law we can use, that can be written as log a square times 3 or log 3a square to the base a. This can be written as log 3a square to the base a. So two terms are given, 2 plus log 3 base a, two different terms. We have converted it into a single term, that is a single logarithm, log 3a square to the base a. Okay, this is the answer for the given question. Now we will move to the next question. Second question, log 32 to the base a minus log 4 to the base a. Even here he is asking us to express it as a single logarithm. Express it as a single logarithm. Same thing here also. Log 32 to the base a minus log 4 to the base a, that is equal to, here this is the difference between two logarithms with the same basis. So we can use the second law, subtraction law or quotient law, that can be written as log 32 by 4 to the base a, that is going to be log 8 to the base a. Okay, as a single logarithm he is asking. If you want to simplify, it can be written as 2 cube and 3 log. Anyway, that is not required. As a single log, you are asked to express it. So that we can leave it like log 8 to the base a. Now, next question. Log 6 to the base a plus log 8 to the base a minus log 4 to the base a, and fourth question also let us write 2 log 3 to the base a minus 3 log 6 to the base a plus log 8 to the base a. Even these questions we are asked to express as a single log. Now solution, if you take for the third question, log 6 to the base a plus log 8 to the base a minus log 4 to the base a is equal to, okay, if you take these two, this is nothing but sum of two logs with the same basis. So we can write it as log 6 into 8 upon 8 to the base a, okay, according to the first law, minus log 4 to the base a. Now if you look at that, these are two logs of same basis and we have the difference between them. So it is a second law, subtraction law. We can write it as log 6 into 8 divided by 4 to the base a. Okay, that is otherwise log, here 4 cancels 2 times, that is log 12 to the base a. So we have converted the logarithms, three different terms we have in the given question, we have converted as a single logarithm. That is the answer for the third question. Now we will move to the fourth question. The fourth question, solution for the fourth question, 2 log 3 to the base a minus 3 log 6 to the base a plus log 8 to the base a is equal to, we can write it as log 2 log 3 to the base a, we can write as log 3 square to the base a minus here also log 6 cube to the base a plus log 8 to the base a. So in this case we have applied the third law or law of powers, that is equal to. Now if you look at these two, log all have the same basis, so I can write it as 3 square times a, because these two are added. So 3 square times 8 upon 6 cube to the base a. Because here the sign is minus, so here we have to write it in denominator place. So there is log 3 square into 8 to the base 6 cube. That can be simplified later. That is log 3 square is suppose 9 times 8 by, here it is 216, or 6 into 6 into 6 to the base a. Okay, so that is 2 times and 3 times, 3 times and 2 times, 2 2s are 4, 2 times, and 2 cancels here 3 times. So that is log 1 by 3 to the base a. That is anyway, that simplification is a next task. Simplification is a different task. Now the concept is conversion of the 3 different terms of the given question we have converted as a single term, that is a single log. So this is how the answer is obtained. Okay, now we will move to the next question. Express log x square y cube z power 4 to the base a in terms of log x to the base a, log y to the base a, log z to the base a. Okay, now how to solve this? We have log x square y cube z to the power of 4 to the base a. If you look at that as a product we have, so we can split it as log x square to the base a plus log y cube to the base a plus log z power 4 to the base a. Okay, we are using the first law. That is equal to, here log x square to the base a you can write as 2 log x base a plus 3 log y base a plus 4 log z base a. Okay, now that is how we can write it as in terms of log x base a, log y base a, log z base a, log x base a, log y base a, log z base a. Okay, this is how we can convert the given question into the required form. Now, next question. Express log 4 to the base 2 plus log root over ax z power 5 upon y cube to the base a in terms of log x base a, log y base a, log z base a. Look at the question. Log 4 to the base 2 plus log root over ax z power 5 by y cube to the base a in terms of log x base a, log y base a, log z base a. Now let us see that. We have log 4 to the base 2 plus log root over ax z power 5 by y cube. I am writing the given question as it is. That is going to be log 4 to the base 2. 4 we can write as 2 square. So it is otherwise log 2 square to the base 2 plus it is log root over. So I better write it as log ax z power 5 whole power 1 by 2 by y cube to the base a. Root we can write as power 1 by 2. That is going to be, this is 2 log 2 to the base 2 by the third law or law of powers we can write it, plus here we can write it as log ax z power 5 to the power 1 by 2 to the base a minus log y cube to the base a. We are using the second law, okay, law of subtraction or quotient law. That is equal to 2 times log 2 to the base 2 is 1 plus it can be written as 1 by 2 log a base a. Okay, here I will apply both the laws simultaneously. Here power law as well as here product law, both we can apply simultaneously. Then we have plus log x base a plus log z power 5 to the base a minus 3 log y to the base a. That is otherwise 2 plus 1 by 2 times log a to the base a, that is 1. 1 by 2 times 1 plus 1 by 2 log x to the base a plus here log z power 5 to the base a will become 5 log z to the base a. 5 times 1 by 2, that is 5 by 2 log z to the base a minus 3 log y to the base a. If you further simplify that, 2 plus 1 by 2 gives you 5 by 2 plus half log x base a plus 5 by 2 log z base a minus 3 log y to the base a. This is how we can convert the given question into log x base a, log y base a and log z base a terms. Okay, so that is how we can solve the problem in this. Thank you.